Hi everyone. So in today LeetCode challenge, we have a problem. The problem name is symmetric tree and the problem number is 101. Alright. So guys, first of all, we are going to clearly understand what this problem says, what we have to do in this problem. After that, we are going to see the logic part. We are going to see how we can solve this particular problem. And after that, we are going to implement our logic in C++, Java and Python programming language. Fine. Now let's see what this particular problem says. So this says given that the root of a binary tree, so we are given the root of binary tree, check whether it is a mirror of itself or not. That means symmetric around its center or not. Alright, so just basically we need to find whether our binary tree is a symmetric tree or not, right? So let's understand this with example 1. So we have in example 1, 1, 2, you can see 1, 2, 2, 3, 4, 4, 3. That is nothing but this particular tree, right? So here if you focus that center is nothing but if I draw a line with blue color, so this is nothing but we can say center, right? So if you focus from here, then left part and right part is exactly a mirror of itself, right? And what is a mirror? If you see on face a person, the left hand and the right hand, they should come here. If I draw with a different color, let me use a different color here. So this is nothing but we can say left hand, and this is nothing but we can say right hand, right? So in mirror, what will happen? In mirror, we are gonna say that this thing. Let me just do. So the right hand, whatever the right hand is gonna come on the left side. So it is gonna come here, and whatever the left hand of that person is gonna come on the right side, right? So this is what actually happened, right? So here also you can see that in this binary tree, 2 is on a we can say the right side. It also on the left side, and of 2 of left 3, it is on left side, right? So it should be on right side of 2, right? So you can see 2 right is 3 and 2 right is 4. It should be left of the mirror. You can see 2 left is 4. I hope this making a sense. That means actually the left part of it, we can say root, should be equal to the right part. I hope this makes sense, right? So left part should be equal to the right part and right part should be equal to the left part of a mirror tree. So by these things, let's assume that whether this is binary or we can say symmetricity or not. So here we have already seen that this symmetricity because this left side is matching with the right side, and here this left side is matching with the right side, and here we can say this right side is matching with the left side. Okay, so now let's see the second example. Here guys, if you focus over here, second example, you can see that the left side is matching with the right side, right? That is making a sense, right? Now this right side should match with the this is the right side, so it should match in the mirror of left side, right? So here, but if you focus here, 2 does not have any left node, so it is not matching, right? It should become on the left. Let me make it a node. It should become on the left side. Then only we can say this is a symmetry tree. I have this making a sense, right? So it should look like 1, then 2, then here also 2, then here if it is 3 on the right side, then it should become at the left side 3. So this is nothing but we can say symmetric binary tree. So it is a symmetric binary tree. So I hope now guys you understood the problem, what is symmetric tree, and now let's see how we can find how we can solve this particular problem. What should be the logic to solve this particular problem, right? So let me remove this thing. So the logic is going to be really very simple if you focus over here, that we don't need to do, we just need to write 4 line of code and we are done with this problem. And what is that 4 line of code? Let's focus is first of all what we need. We don't need to jump to the right to the code, we need to understand the logic behind the code, right? So what we actually need, one thing I am sure that, and I have to write it here that as well, the left part. So let me just write a root. So root of left side should be equal to the another root of means mirror root. Let's assume this is root 1 and this is root 2. So if you wanna, we can say compare with this example 1. So let us assume this is root 1 in example 1 and this is root 2, right? So root left should be equal to root right. Is that making a sense? I hope, right? And root, let me take a different color. Root right should be equal to root left. I hope this making a sense. If this making a sense, then definitely you are getting a particular logic right now. If this is making sense, right? This is nothing but a symmetry, isn't it? So left part should be equal to right part. So can we say that if root left, let me just make a function here. Just I'm gonna write a pseudocode so that you can have a better idea. So I'm giving a function name. Let's say function. I'm just writing pseudocode function. It's gonna take two value. First is root 1. First is second is root 2, right? So what we have to do? This box is nothing but we can say base condition. So in this box we are going to write a base condition, and that thing we'll discuss it later on. But first of all, what are the logic we are going to do? So we are going to say in this box, if first of all root value should be same, right? 2 and 2 should be same. So we can say if root value are same, then if root value root 1 dot val is equal to root 2 dot val, then only you can proceed, right? So root 2 dot val, right? If it is not equal, then you can return false. I hope this making a sense, right? So we are going to return false. But if it is equal, then it's going to proceed further. And here we are going to check the same function for left side. So root 1 dot left, comma root 2 dot right. I hope this making a sense. What I have done now, I'm saying that this function, so just check it. Assume that now this is not your 2 of 3. If you take this particular example 1, so let me remove all these things. First of all, we are going to assuming that, just assume yourself, if this is a node, right? If I am standing here, this is root 1. So let me write root R1, and this is R2, right? So now assume that this left side is should be equal to right side, right? So I'm going to say now the next function should have this particular root R1 and this particular root R2. And for another side, this should be the R1 and this should be the R2. And you can proceed following the particular subtree of this particular one as well, right? So just what I'm doing that, I'm just saying that this thing should be true for left side. You have to take root 1 left and root 2 right. And same thing you have to take fun. So let me write fun. Root 2, root 1 dot right should be equal to root 2 dot right, root 2 dot left, right? So if these two functions are going to return recursively true, that means this particular full tree is also going to be true, right? So just we are dividing our tree into two part. Here, if you focus here, we have divided into two part. If I just again remove these, and I'm just telling you in the brief as well. So first of all, we were having this thing, right? So this was a root 1 and this was a root 2. I hope this making a sense, right? After that, what I have done nothing. I have just divided into two part. First was this was a root 1 and this was a root 2, right? So I have said that now assume that this is nothing but this is a root 1 for you and this is root 2. And whatever the child they are going to have, let's assume that they have some child. So I'm going to assume that, so they are having some child, right? So they are having some child. So whatever that come in green, this is going to be nothing but root 2, right? And this is also going to be root 1. If this is a true, and this is also going to be root 1 in some another function, and this is going to be root 2, right? If these two are true, if we can say these two subtrees and these two subtrees are true, then you can say this is nothing but a binary, we can say a symmetry, right? So assuming that this, first of all, to check this particular thing, we are checking these two are true, right? 2 and 2 are true. If these two will return true if their left subtree is going to be matched with the right subtree, and their right subtree is going to match with the left subtree, right? So then I mean to say that the left subtree should be the mirror of right subtree, and the right subtree should be the mirror of left subtree. So that thing is function. This function is going to do. Just focus over clearly. Function root 1 dot left should check with the root 2 dot right, and root 1 dot right should check with the root 2 dot left, right? And what will be the base condition? Base condition will be both are null, then return true. If both null, return true. Means if both are null, that means true. If any of the node is, we can say, exist, right? Both are, one is null and one is exist, then you can return false, right? If one null and other exist, right, and other exist, so other exist, so return false, right? And if value is not same, then also return false. So I hope this making a sense. So this was nothing but we can say a pseudocode, and we have seen the logic part. We just recursively calling the left side with the right side of other roots, and the right side of first root with the left side of other root, right? So let's see the logic part, implementation parts, and how we can implement this logic. And definitely it's going to be very easy, full line of code. So let's jump to this directly to the code and see how we can write this particular code, right? So first of all, I'm with the Python, so I'm not going to take much time. So I'm just going to define one function. So function name you can give anything. I'm going to give sol, fine, and this is going to take two root 1 and root 2. Okay, and if root 1 is not exist, right? If root 1 is not active and root 2 is also not exist, then if both are not exist, then return true, right? But if some one exists, if root 1 or not root 2, if one exists, then return false, right? And if root 1 dot val is not equal to root 2 dot val, value are not same, then also return false. We have seen this. And if value also same, then we are going to see the left part with the right part and the right part with the left part. I hope you are getting it. What I'm trying to say, I'm going to say that return now solve of root 1 dot left side with the root 2 dot right side, and solve root 1 dot right side with the root 2 of left side. And by this I have solved, can say I have solved this particular problem. Just I'm going to call this function. So I'm going to say return solve root dot left, root dot right. So I'm going to say root dot right. So let's run this particular code and see whether it's working fine or not. So I have to use a self condition here, right? So because I'm using outside, so you can see that I got an error. So I'm going to say not here self, and here also self, and here as well self, right? Now let's run this code and see whether it's working fine or not. And one more error because root 2 is not there. There is only root. So now let's see. We got two error in this Python code only. And here you can see that both the test cases are passed, right? Isn't it? So let's try to submit this code. This is very easy code, isn't it? So let's submit this. And just what we are doing, we are just checking for the left side with the right side of root 2 and right side with the left side of root 1, right? So it got successfully submitted. So now let's move to the second programming language. That is nothing but we can see. Let's look at C++. So here I'm going to just define one function that is nothing but with the name of bool return type, and the name is soul, and it's going to take tree node root 1, and let me add root 1, fine, and tree node root 2, right? Now what we are going to check, we are going to check if root 1 is equal to null and root 2 is equal to null ptr, right? Not null, either I have to use in capital case, right? So if both are null, then return true. If one is null, if root 1 is equal to null ptr or root 2 is equal to null ptr, then what we are going to do, we are going to return false because one can't be exist, right? It has to be symmetric, so both nodes should exist. So true, not true, we have to return false. And here also we are going to check the value. So we are going to say root 1 well, if not equal to root 2 dot well, then what we are going to do, we are going to say return false. Now we know that if value is false, then value are not same, so it's going to return false. But if it coming to 89, that means value also same. So value also same. Now check for the subtrees. So if now we are going to say return soul, I'm going to check first of all root 1 left side with the root 2 right side, and soul root, let me add root 1 right side with root 2 left side. Fine, so we have done this thing. Now let's particularly call this function. So we can say return soul root left side and root right side, right? Now let's run this code and see whether it's working fine or not. And you can see both the test cases are passed. So submit this particular code and let's see whether it gets submitted or not. And here, yes, it's successfully submitted. Now let's move to the last programming language, that is nothing but we can say Java. And let me define the function. So I'm going to say public boolean soul, and here I'm going to give a tree node root 1 and tree node root 2. All right, so I'm going to check it if root 1, we can say root 1 is null and root 2 is null, so we can say return false, or sorry, return true, right? And if one exists one other node, so we can say root 1 is equal to null or root 2 is equal to null. So we can say let me write 2, so we can say return false. Fine, so let me write false. Now we are going to check the value. If root 1 value is not equal to root 2 value, so we can say return false. Now we're going to solve recursively, value also same then, so we can say return soul, and here we're going to call root 1 dot left with root 2 dot right, and root soul, let me call this soul root 1 dot right root 2 dot left. Once this is also done, just we are going to call this main function soul function from the symmetric function soul root 1 dot left and root 2 dot right, right? So we are going to say return this particular part, whatever this is going to return, and let's try to run this code. And to be summarize this, first of all we are checking whether both nodes should be exist or not. If both are not exist, then also we can say this is nothing but true. So first of all, let me see whether we got an error. So I have to use a root 2 only, not root 1 root 2. All right, so let's run this code. And first of all, we are checking here whether both node exist or not. If both node are not exist, then we can say return true. Then it's symmetric because nothing is on the left side and nothing on the right side. But if any of the node exists, means something exists on the right side and not on the left side, and something exists on the left side, not on the right side, then we can say return false, right? It can't be exist. You have one hand in the mirror, but you don't actually have that particular hand, right? But if both node exist and their value are not same, then also we can say they are not symmetric, right? If your hand has 4 finger and their hand has in the mirror the hand has 6 finger, then will it be symmetric? No, isn't it? Now the value should be same. If value also same, then check for the left side and right side. And we have already discussed in team why we are checking left with the right and right with the left, right? Now let's run this particular submit this particular code as well, and you can see that, guys, right? It successfully got submitted. Runtime 0 millisecond. All right, so we have successfully solved in C++, Java, and Python. I hope you like it. If you still have any kind of doubt, you can ask in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.